Hi everyone, and welcome to part 2 of the series where we are solving simultaneous equations by substitution. And so now we have another set of simultaneous equations. Let's go ahead and label them, equation 1 and equation 2. Now what looks tricky about these two equations is that we have fractions and a lot of fractions. But actually, it's not that hard. The key idea is we want to manipulate the equations so that we don't have to deal with fractions. You see what I mean as we go along. So let's first take equation 1, and let's say we want to manipulate it so that we don't have to deal with fractions. We see that equation 1 is a whole fraction equal to a whole fraction. When this happens, what we can do is we can do something that we usually like to call cross multiplication. Now I won't go through the actual process of cross multiplication here and the reasoning. I think that can be found in a different video, perhaps somewhere down the road. But right now, equation 1, let's just use the result of cross multiplication. So 3 multiplied by x minus 1, and that is equal to 2 multiplied by y minus 3. And then now let's do a little bit of expansion and simplification. So we have 3x minus 3 equals to 2y minus 6. And maybe let's leave it like this for now. And now let's move on to equation 2. For equation 2, we also want to get rid of the denominators, right? So let's cross multiply as well. And what we get is 5 times x minus 2 equals to 1 times y minus 1. But of course, as we know, when we multiply something by 1, we don't actually have to write the 1. So let's just write it like this. Let's expand a little bit. 5x minus 10 equals to y minus 1. And the reason why I stopped here is because we want to make x or y the subject. And so we don't know which equation is best for us to do that. But now that we've gotten rid of the denominators, I think it's clearer for us to see. And so let's study both equations, the one in blue and the one in yellow, and let's see which one is easier. Oh, we see that y over here already has its coefficient 1. So that will be easy. That will be much more convenient. So let's take this equation and let's say it is 5x minus 10, and we want to make y the subject. So let's add 1 to both sides. That gives us y equals to 5x. Negative 10 plus 1 gives us negative 9. Done. So let's call this equation 4, and let's call this equation 3. So equation 3 came from equation 1, and equation 4 came from equation 2. So really we are solving for equation just 3 and 4, and that will be sufficient. So let's do that now. Let's substitute equation 4, where y is the subject, and let's substitute 4 into equation 3. Now you may ask, why don't you substitute equation 4 into equation 1? Well, you can. You'll get the same answer, but it's more difficult because you have a lot of fractions to deal with. So the very reason why we cross-multiplied was because we wanted to get rid of the fractions, express it not as fractions, and then we solve. So let's substitute equation 4 into equation 3, and equation 3 looks like this now. It will be 3 times x minus 3 equals to 2 times y, but y was 5x minus 9, so y is now 5x minus 9. And then, of course, we just finish up the equation. You can see that y is gone, so let's just simplify, and we'll be able to solve for x. And so we have negative 3 equals to 7x minus, so negative 18 minus 6 equals to negative 24. And so 7, let's add 24 to both sides. 21 equals to 7x. And so 21 divided by 7 gives me 3 plus x. I like to write it as x equals to 3. Good. Now let's just take x equals to 3, and let's substitute it into any equation So once again, we've already made y the subject here, so that's convenient. So let's just use that result from equation 4. So we substitute x equals to 3 into equation 4. So we get y equals to 5, x equals to 3, so 5 here. Yep. And so we get y equals to 15 minus 9, and y thereby equals to 6. And there you have it. So x equals to 3 and y equals to 6. We're done.